Hi, Marc. How are you?
Hey, I'm fine. Thanks, Molly. How are you?
I'm good, thanks. So, you work at Gradle and you're a contributor or maintainer for JUnit. So
That's
basically,
correct.
you're building all of the stuff that we use on a daily basis.
Well, some of it, yeah. So whenever there's a problem with testing, I'm
Yes.
pretty much to blame. Yes. So, yeah.
Yes. All right. So, how did you get into contributing to JUnit? Because I read you were first an Erlang programmer and then got into Java. How did that happen?
Well, I was working with Java before I got into Erlang, so that has a longer
Okay.
history. But yeah, like while we were working on JUnit 5, I wasn't actually working with Java for some time, but was working on the back end in Erlang. So that was kind of interesting.
So you were doing Java open source while working in Erlang for your day job
Yes, it
for
was like
fun.
functional, dynamic typed, during the day, and then static typed, object oriented at night. Yeah, basically, pretty much.
Okay. Okay, because it wasn't challenging enough.
Well, it's interesting. I mean, Erlang has some nice features that Java yet doesn't have, like pattern matching, like full-fledged pattern matching, and things like this. So definitely, got me thinking. Yeah.
Cool. Cool, cool. So you're going to talk to us today about evolving JUnit 5 and what we have to look forward to, I guess.
Yeah, very much like the highlights of what happened since
Awesome.
5.0, and yeah, a few things that will come next as well.
Well, I love using JUnit, so I look forward to learning more. Let me add your slides to the stream, and I'll remove myself and have fun.
Thanks. All right. Yeah, so I don't really have to talk much about this one, right? So I got into JUnit quite a while ago. I'm the JUnit team lead since 2016, actually, and we had this whole crowdfunding campaign to get this thing started called JUnit Lambda. That was all like ancient history now, because as of this September, JUnit 5 actually has turned 5 years old. So it was launched, like the 5.0 release was in September 2017. And it's 5 years later already. Time flies. And as you can see here, we've been busy. So there have been 9 feature releases and also numerous patch releases in the meantime. You can maybe see it, the frequency slowing down a little bit, but we're still actively working on it, of course, and also have some more things in store that we want to work on. So today, we're gonna cover like how to write tests actually with JUnit. I mean, I think that's kind of obvious, but also how to write extensions with JUnit. That's JUnit Jupyter. And then the second point is the JUnit platform. What is that? Why do we need it? And then at the end, we'll have some more resources to get you started. And I'll also talk a little bit about like, okay, what's on the horizon? What will be next for JUnit? All right. So first of all, JUnit Jupyter, the modern testing framework for Java, according to us at least. So in Jupyter, what is that? It's an API for writing tests and extensions. And it requires at least Java 8, so that hasn't changed since the 5.0 release. And we are actively testing it, not just with Java, but also with Kotlin and Groovy. So that's also kind of supported, even though Java is the main use case for us. And we're trying to be a good citizen, so it ships with Java module descriptors and OSGI metadata. So basically that all like the ecosystems can directly consume the jar files. This is not just true for the Jupyter jars, but for everything else as well. All right. So what's the basics? Like, what does a test look like in JUnit? And if you have ever written a test with JUnit before, this will look familiar, right? So you'll have to define a class. In this example, it's called tests. And then you have to write a method and then annotate it with the test annotation. If you're familiar with JUnit 4, what's different here is the package you import this from. This is now the Jupyter API package. And the assertions are the assertions class in that same package. And you will see many of the familiar assertions in that class, but there's a few new ones, like assert throws. That's you really fine granularly assert exceptions in blocks of code that you pass as lambdas, or assert all, where you can check multiple conditions. It's not a full-fledged, super flexible assertion library. There's AssertJ, there's Hemcrest for that. We didn't want to reinvent the wheel, but it has the basics, so you can get started with writing assertions. If you have special needs, you can pull in an additional library. And another thing that you might notice here in this example is there's no public notifier. It's a small thing, but it's slightly a boilerplate, so you don't have to make your test classes public anymore, and neither the test methods. There's also still lifecycle methods. So lifecycle method is something that is called, in this case, before each test method. There's also after each, which would be called after each test method, and before all and after all for something that you want to prepare on the class level. And yeah, these annotations, they work like the similar annotations in JUnit 4, so you can still use that style to prepare your tests. But there's new things. So one thing that's really, really cool is display name. So display name is something that lets you write natural language text as a string, basically. So you can put that on the class level, or you can put that on the method level of your test. And yeah, that's to be more expressive in describing what the test is supposed to test, what it's supposed to do, right? You're not just limited to the names in the method anymore. Camel case only goes so far. There's things that you know, like ignore, but it's not called disabled. And there's also a more flexible way of tagging tests, which is the tag annotation, which just takes a string instead of a class literal. But all in all, yeah, the basics still look pretty similar, but there's a nice few additions that come with Jupyter compared to JUnit 4. And display names, you can also take that a step further. There's an extensible API that also lets you generate display names. So in this example, we used the built-in replace underscores display name generator. And then that would generate a tree of tests in your IDE that would look something like this below, right? This one simply replaces underscores with spaces, but you can write your own display name generator that takes a look at other annotations or whatever. And you can also configure a default for all your tests via some configuration parameter that you can put in a properties file, so it's applied to all your tests, or you can specify it via system property. Another new thing in JUnit Jupyter is nested tests. So here's an example where we test a stack, and you can see two levels of nesting here. So this is the top level class called stack tests. We have a nested class called when new, and one that's called after pushing. And this lets you build like context, basically. Yeah. So we have a stack on the top level. Initially it's empty, so we can write some annotations for the empty state. Then we push an element in this before each method that's only applied in this kind of second level nesting context. And then all the tests in that nested class can use that state, for example. This is useful in some cases when you go into group tests, where you have kind of similar setups or teardown logic that you want to reuse. It doesn't have to mean that you have to use this in all your tests, of course. There's also some special support for Kotlin. So we have some top-level functions or extension methods that you can use to write more idiomatic assertions in Kotlin. Like, as you can see here, we have 3 imports. The first one just is the regular static method from the assertions class, but there's 2 top-level kind of functions here that we import from the Jupyter API package. And for example, assert throws lets you use like reified kind of generics here to write this in a more Kotlin-friendly way. And then you can use this assertion easier than with just the standard assert throws method if you had imported that. And similar for assert all, also lets you kind of pass in these little closures here, so you can test that more easily. Another thing that's not just for Kotlin, but Kotlin was a strong use case for it, is the test instance lifecycle. So by default, in JUnit 4 and in JUnit Jupyter, it's the same. You get a new instance of the test class for every test method. So that ensures you don't have, by default, you're not relying on any kind of side effects. If one test has stored something in a field, the next test can read it or something like this. But in some cases, it can get in your way. And Kotlin is one such case. For example, here we have a before all method, and usually before all methods have to be static because we don't create a test instance for them to invoke them at all. But in Kotlin, it's really cumbersome to write kind of a static method. You have to have a companion object, have to put JVM static on that function. So it's really cumbersome. And this one lets you just change the lifecycle, the test instance per class here. The annotation configures this differently. And here you get one test instance for the entire lifecycle of this test class, which also means that the before all methods don't have to be static anymore. I could just write the code in a more easy way. Another thing that JUnit 5.3 actually introduced was parallel execution. So by default, tests are run sequentially, but you can opt in and change that. And you can even make them run concurrently by default, all of them. And then you can use the execution annotation here to opt out if you want, or you can do it the other way around and opt in using concurrent. And there's also some basic kind of high-level synchronization primitives that you can use. You can annotate your classes or methods with this resource log annotation here, for instance, just to declare, okay, I'm using this thing with some key, either in read mode or in read-write mode, and then JUnit will ensure that no two tests that conflict with that resource would run at the same time. So it's kind of like locking conceptually. And there's even a more simple way introduced in 5.7, which is the isolated annotation, which basically, if you have that on a method, JUnit will not run anything concurrently to that method. It will only run this thing in an isolated way. As I said, it's just the highlights today. Otherwise, I would have done a demo for this, but time is too short. But we have a demo coming up, namely more ways to test. So we have seen a test method here. But there's other things that you can do to test your code. So this is an example project that I've prepared. It's just using Jupyter here in the latest version and Java 17. There's not much else here to see. And what I'm going to do is I'm going to create a new class called math tests. And then I'm going to create a test method. And in this first test, I want to test the square root function of the Java math class. So I'm going to use assert equals and say, okay, I want to test that the result of taking the square root of 4 is 2 with a precision of 0.01. And yes, I want to import this. Oh, come on. There it goes. All right, so this is like the first simple test. This is nothing fancy, but we've seen this on the first slide with the basics. And I can run this test method here. And as you can see here below, it's green, everything works. Okay, with such a function, you usually want to test it with more than just one set of parameters, right? So that's what we're going to do next. So how can we write a parameterized test with JUnit Jupyter? And what I'm going to do here is I'm going to basically extract some parameters, so we can see this kind of, okay, this is expected. No, this is actually the input, I'm sorry. So this again, and the other thing is expected. Already said so, okay. IntelliJ already tries to warn me here. And if you want to run a parameterized test, you have to use the parameterized test annotation. That's one thing. And then you have to tell JUnit where the parameters actually come from. There's multiple ways of doing this, of course. For here, we're just going to use CSV source and going to use a text block to specify the CSV. There's other sources. You don't have to use CSV, of course, but in this case, we're going to do that. So the input was 4, and we wanted to have 2 as a result. We can run this, and then we can see here, okay, 4.0, 2.0, which is not very readable, but we can adjust the name. So we can say square root of the first argument equals the second argument here. So like a message format. And then we have square root of 4.0 equals 2.0 here as a result. So that's much more readable. And now we can easily add more, like we can say 9 is 3 or 2 is 1.41, and then run this again, right? So we could easily add multiple more combinations of arguments here, of course. So this is a very brief demo of parameterized tests. Moving on to the next example. So here I want to write something that is flaky. And usually you don't want to write this, but sometimes you have something like this, and then you want to kind of check, is it flaky or what's going on? And my silly example here, I'm just going to assert that math random, which returns a value between 0 and 1, is 0 with a precision of 0.9. So let's run this. It's green. But is it always green? Let's see. So we can use repeated tests and easily run it 100 times. And then we see, okay, tests failed. 8 of 100 failed. So this is clearly flaky. And I mean, in this case, it's obvious why it's flaky, but sometimes you have these tests in your production code bases and you're not sure if you have some concurrency issues still. And this is just an easy way of running it multiple times. All right, let's move on to another example. So we want to test that even numbers are divisible, hard word, by 2. All right, so but we're not going to do this in a normal way. We're going to use test factory. So a test factory method is something that Jupyter also provides. It lets you create tests. That's why it's called factory. So you need to return something. In this case, we're going to use a stream, and the stream is a stream of dynamic tests. So the first thing we need is even numbers, and because I'm just going to use an int stream for that. I'm going to start with 0, and if we have an even number, we're just going to add 2 to it to get the next even number, right? That's simple enough. Okay, now that we have an even number, we want to write our test for it. And the first thing we're going to say is we need to create a dynamic test. And the dynamic test has 2 parameters, a string and an executable. The string is the name of the test. So we're going to say n is divisible by 2 as the name. And then comes basically the body of the test, would normally be the body of the test method. And in our case, we're going to assert that, n modulo 2 is 0. That means divisible by 2 in Java, right? And before you run this, we should limit the stream, because otherwise we get an infinitely running test. We don't want that here. So we're just going to say, let's run 1,000 of these. And we run this, we can see, okay, tests passed 1,000. And we can see here all these kind of even numbers were checked. Everything is green. Just to see it break, you're going to use all numbers for change. And then we should see half of them failing, right? 500 failed. So of course, odd numbers are not divisible by 2. So that obviously fails. All right, short recap of this. So parameterized tests are really useful. They can have different sources. So we've seen CSV source here, right? But it's just one of them. You can have the CSV source in a file. So for example, in source test resources or somewhere, you can just use value source and supply a list of ints or strings as kind of parameters to the annotation. You can use enum source and pass the enum class, and then you will get all the enum constants as inputs. You can use method source to call a method in your test class or even some other class via some naming convention. And IntelliJ also has some nice support for this, for navigation. And yeah, you can of course also write your own provider. So there's this argument source annotation that lets you specify something else. So you could read from a JSON file or something else, a database, whatever, right? Basically, you have full flexibility with this. And then also we've seen repeated tests. They're useful mostly for flaky tests and then just trying and seeing if this is really stable or not. And test factory to produce dynamic tests. We've just kind of seen the tip of the iceberg there. You can even nest them with dynamic containers and things like this. But yeah, that's not something we have time to do today. So that's very brief how you write tests using JUnit Jupyter. I also want to talk a little bit about extensions in Jupyter. So why would you want to write an extension? Well, you want to extract some behavior that you want to use in kind of multiple tests in some reusable way, right? You could, of course, create some superclass for your tests, but that doesn't really scale. You can only have one superclass. So extensions are a way around this. You can have a kind of extensions as many of them registered at the same time as you need. They should not conflict with each other, and this is fully supported. And they allow you to hook into the test discovery and also the execution. You can, change the behavior of JUnit this way. And ultimately, what this allows is to have more concise tests and make it simpler to write them. So let's see an example. So the silly example here is we have a test, and we want to disable it on certain weekdays. Like today is Friday, right? And I'm speaking at this conference, so I don't want to be interrupted by tests that are failing. So if I run this now, this fails because I have failed here and it says fix me. So why does it fail? Well, obviously, right? But I have this disabled on weekdays here. Does this do anything? What is this even? So this annotation is just defined here locally. As you can see here, it's in the same package. It's here. Just an annotation with runtime retention and target method, nothing special, right? So actually this is not implemented yet. So we're gonna do this, right? We're gonna say, we wanna register an extension whenever this annotation is present. We want to register our extension that disables tests if the weekday is actually one of those weekdays specified in the annotation. So let's do this. You can, of course, implement this as a top-level class. I'm just gonna do this in here for the sake of simplicity, so that we don't have to jump around as much, right? So it's in here. And you can see IntelliJ has picked up on the need to implement extension, but extension is only a marker interface, as you can clearly see here, right? There's nothing in here. If you look at the hierarchy, there's lots of sub-interfaces. And for now, we're interested in this one, execution condition. So that's what we're going to pick here. And you have to implement one method for this, which is called evaluate execution condition. And it gets an extension context. So the extension context itself, that's something that most of these kind of extension interfaces and the methods that you have to implement get as a parameter. It allows you to see, okay, what am I currently about to execute? Like, what is this? What's the display name of this test? What are the tags? What's the test class and so forth? What's the test instance, right? You can basically look at all of these things and then decide on what you want to do. In our case, we want to look for this annotation actually here that we're in, right? So that's what we're going to do. And there's a support class we can use for this called annotation support. So we're going to get the annotated element out of that context. It's an annotated element, which is the superclass of kind of the reflection API for a class in Java or a method. So basically, when we use this, we're already making sure that we're not depending on whether this annotation is declared on a class or on a method. All right, so we're going to find this annotation here, and then we get back an optional. Maybe the annotation is present, maybe not. So let's say it's present, then we want to map it. And then we want to filter. So we want to check the day of weeks that we have in the annotation. If any of them match today. And today we get from local date. Now get day of week. It's getting a bit unwieldy here, so let's extract this to a local variable. Current day of week. Static import here. Okay, so we filtered. Now, if that's the case, we have an optional that is not empty. We don't really care for the value, so we're going to ignore that. but we need to return a condition evaluation result. And what is that? It's basically a Boolean, enabled or disabled with a string, namely the reason for it being enabled or disabled. So in our case, it's simple. If the day matches one of those days in the annotation, we're going to return disabled. And we're going to say today is that day. Otherwise, we're just going to return, that's wrong, enabled, of course. So we need to get some work done. And then we just need to return this. All right, going back to the demo, test class. So when I run this now, it should be successful because the test was skipped. And it even provides the reason here because today is Friday, right? Just to double check, let's say it's Saturday in the annotation, and then the test would be executed and fail because it's not actually Saturday, it's Friday. All right, that was the really short demo about extensions. Like we've seen the extend with annotation to register an extension, but there's actually multiple ways of doing that. You can use extend with on classes and methods. We've used it on a method indirectly via some other annotation, but you can also use it on fields and parameters since JUnit 5.8. So you can have a parameter on your test method that specifies something, and then it can automatically register an extension that performs the injection for that parameter, for example. You can also use the register extension annotation if you want to have some control, pass some parameters to the extension class's constructor, for example. You would programmatically instantiate this extension on a field of your test class and then use the register extension annotation for that. A third way is you can also register extensions globally. So then you need to register them via the service loader mechanism of Java. And you also need to set some opt-in flag to kind of register global extensions via a configuration parameter. That would allow you to register the extension for all your tests without even mentioning it in the source code even once. We've seen this extension implementation. There's a marker interface called extension, but there's actually a lot of sub-interfaces for this. And the important thing, the point I want to make here is if you implement an extension, you can implement as many of these sub-interfaces as you want. They are composable. So for example, you could implement a before each callback and then after each callback to do something before and afterwards, clean this up again. So there's a lot of these extension interfaces. This would be worth a separate talk. So I'm not going to go into any detail on them. Just know that they're there. And there's a lot of documentation also and examples by now that you can take a look at. There's also some support classes. So if you want to implement an extension, there's help. We've seen annotation support. If you want to look up annotations on the test method or test class. There's also a class called reflection support that you can even use to scan the class path for something or execute a method on your test class or whatever, right? Whatever you can think of in reflection terms, you can do with it. One thing that annotation support provides you is a way of looking up annotations, not just in a regular way, but also looking up composed annotations. What is a composed annotation? Well, we already seen one basically. We've had this disabled on weekdays annotation here. We added the extend with annotation, but you can add additional annotations to that. So for example, here we also added the tag annotation, and these two annotations are used to compose this annotation that is defined, and are used as meta annotations in this case. So this means whenever JUnit sees a disabled on weekdays annotation on a test method or a test class, but you're actually looking for an extend with annotation using annotation support, JUnit will find it. So that's some added benefit that you would get from using those support classes. There's also a lot of built-in extensions. I'm briefly going to talk about them as well. So temp dir support is one that's often useful if you want to work with files. You need some kind of temporary directories. And tempdir is a declarative way of injecting a tempdir, for example, into a method as an annotated parameter. You can also use a field, of course. It supports multiple tempdirs since 5.8. So if you have 2 parameters here with tempdir, you get 2 of them. And you can even configure the cleanup mode since 5.9. So for example, you configure by default, it cleans up all the files in the tempdir, but you could change that to never clean up or to only clean up if the test was successful. For example, if it failed, you might want to look at those files and see what actually happened. Another thing that's built in and also implemented using extensions is timeouts. So since the beginning, since 5.0, there was the timeout assertion method, right? That lets you kind of assert timeouts within a code block, within a test. But since 5.5, there's also this declarative way of defining a timeout using an annotation. And you can put the timeout annotation on a test or a lifecycle method. And you can also configure which thread it gets executed in the test, that is, which is important for some detailed use cases. But the clue is, like, if you want to ensure, for example, on CI that all your test methods use some rather large timeout so they don't kind of, let the build run indefinitely, you can even configure that globally now via this configuration parameter and enforce some timeout on all of your methods, unless they override it, of course. There's also a lot of built-in execution conditions, like the one we implemented, but in a more meaningful way. So, for example, you can disable or enable tests based on the operating system, the JRE, and other things. But one thing that I wanted to point out here is also the architecture is something that is new since 5.9. Now that M1 Macs basically are kind of ubiquitous, this is something that has become important to check for the architecture, for example, on some tests, because sometimes you have native libraries and some tests don't work on some architecture or only work on some architecture. There's also built-in conditions that check system properties or environment variables for some value, some regex that you can supply here. There's enabled or disabled if, which lets you specify a method reference that would be called and has to return basically whether or not this should be enabled or disabled. And just recently, like the 5.9 release, which was last week, we added this enabled or disabled in native image annotation. So if you use Gradle VM, then this would basically enable or disable your tests, depending on whether the test runs in the native image. Also, there's a lot of third-party extensions. I want to point out a few here. There's JUnit Pioneer, which is a project that is kind of associated with JUnit in a way. So we closely collaborated with the maintainers of that project. They basically want to provide an extension pack for JUnit with a mixed set of extensions. There's also a very great support for Spring here. There's Mockito, test containers, all of that. And we collect these extensions actually on this wiki page. So if you know of one that's not on this list or not on the wiki page, which has the complete list, please let us know or add it yourself to the wiki page. All right, so that was the first item on the agenda. How to write tests and extensions using JUnit 5. I think we have some time to pause for questions if there are any.
Hi, Marc. Anna, our moderator, is doing a great job of answering questions in the chat. So I think we don't have any open questions at the moment. And also, Christian Stein is in the chat answering questions, also from the JUnit team,
that's cool.
I think. So they have you covered, and you can just continue.
Great. All right. Yeah, I'll do that.
All right. Thanks.
Cool. Yeah, it's always nice if the team chimes in on the chat. Thanks, Christian. All right. So I can hardly do a talk about JUnit 5 and not talk about JUnit platform. So this is next. When we set out to kind of redesign how JUnit works, we had this separation of concerns in mind. We wanted to fix some problems we had with JUnit 4, which was just this one jar file, which was really not that great at maintainability and everything. So we wanted to separate concerns. Namely, the first concern is obviously you want to write tests and extensions, so you need an API to do that, but that should be separate from the way you run things. So we also needed an API on the other side, which is the third point on the slide, for execution of tests by tools like IDEs and build tools. So that's the launcher API that we'll see in a minute. So these two should be clearly separated. And in the middle, we need something that knows about, okay, what is actually a test and an extension? And so that would be called by this launcher to discover and execute tests. And it should be extensible because we wanted to support multiple ways of writing tests. We wanted to be flexible in the future. And we also wanted to allow that people could run JUnit 4 tests and JUnit 3 tests even on the new platform, while also being able to write Jupyter tests and run them at the same time. So on a very high level, the architecture looks like this. So you have IDEs and build tools in the bottom of this picture, and they use the platform in the launcher API. And then you have these colored boxes like Vintage and Jupyter and third party here, which are actually engine implementations that also kind of tie into the platform. But there's no direct kind of dependencies from the IDEs and build tools to those engines. It's all decoupled. So when we say JUnit 5, we actually mean Jupyter and Vintage and platform. And Vintage actually is the engine that lets you run JUnit 3 and JUnit 4 tests. But there's also other engines. So Spock framework, I recently wrote one for TestNG. There's other kinds of test engines like JQuick, which is for property-based testing. Cucumber, a bunch of engines for Kotlin like CodeTest, and a lot of others. And we also collect them on this wiki page. So the platform is really open for extension. And you can even mix engines in one test run. So this is an example from the JUnit samples repo. You can see a test tree on the right here. And this is actually mixing, I don't know, 7, 8 test engines here in a single test run. You normally wouldn't do this, obviously, right? You could use this to, for example, gradually migrate from one test engine to the other. So for example, you might have an old project where the tests were written in JUnit 4, and you want to write the new tests in JUnit Jupyter. What do? Do you have to migrate all of them at once? No, you actually don't have to do this. You could write a new test in Jupyter, and then if you want, you could gradually migrate the old tests. Or there's even use cases where it makes sense to have multiple test engines going forward. Like you could use ArcUnit to write architecture tests, or a Cucumber to write more kind of, user-facing tests, and usually something else for your unit tests. And it would be perfectly plausible to do this. And the JUnit platform allows you to run and mix engines and get all the results in a single test run. A new feature in 5.8 is the declarative test suites. And this is actually also implemented as a JUnit platform engine, so the suite engine. And it allows you to define a class and add the suite annotation to it. And then you can basically select the tests you want to run. You have all the selectors that the JUnit platform supports, like packages, classes, directories, files, class path resources, modules, everything. You can also define a couple of filters. In this case, we're filtering by class name patterns. So we only want to run classes that end with tests. And that's it. You can run this, and the JUnit platform suite engine will pick it up. And the result will pretty much, oh, that was wrong. It pretty much look like this, which actually the suite tests class that we see here at the top node is actually such a suite class that is executed using the suite engine. Another thing that the platform provides is tag expression filtering. So you can precisely specify which tests you want to run based on tags. You can use this to include tags or to exclude tags. And as you can see down here, we can use expressions. So it could be just one tag, which is the simplest expression possible. But you can also use kind of Boolean operators here and say, I want to run all the tests that are tagged with smoke and feature A, or not with smoke and feature B, right? So you have lots of flexibility here to precisely specify which tests you want to run. You could use this, for example, to separate your unit tests from your integration or functional tests and have different test tasks or different targets for that. Another thing that the platform also contains is called test kit. This engine test kit class allows testing extensions that we've seen, or even test engine implementations, where its name actually comes from, in tests. So it's an API that you can use in your tests to run tests. So here basically is the entry point. You say, okay, we want to run a test using the JUnit Jupyter engine. We give it selectors. So this is a little bit like what we just discussed on the suite class. In this case, we want to select this example test case class for running, and then we say execute. And what we get back is a collection of results, and it records all the events that happened during test execution. And we can use that to write assertions for such tests. For example, here, we're using this assert that events have exactly one event where it's a test with skip test in its name, and it was skipped for a certain reason. So for example, if you had written an extension that would use this reason in this condition evaluation result that we've seen earlier, you could test your extension with this. And last but not least, since 5.9, there's actually a new XML reporting format, finally. And this specification for this is called Open Test Reporting. It's in a separate repository. So we've really tried hard to keep it even independent of JUnit and independent from Java even. So the specification is in a separate repository under the Open Test Alliance organization on GitHub. Yeah, and we've written a kind of default or kind of demonstration implementation in JUnit. So it's really simple if you want to use this and then try it out to do so. All you have to do is basically set this system property on your test JVM to true, or specify it by some other means as a configuration parameter. And the idea of the new format is that it has full support for all JUnit platform features, such as hierarchical test structures, display names, tags, and all that metadata that is really helpful when you want to reason about test results. And it also should be extensible. So we want to really have this format. It can be extended via additional XML schemas, and it allows you to be kind of precise what things mean in those schema specifications. There's actually two formats. So the first one is rather technical, which is this one. So this is from an example test run that ran one test method, flat default, in a nested class, demonstrate palettes test in the top level color palettes test class using the JUnit Jupyter engine. And you can see there's like a started event for every level and a finished event as well. So the IDs kind of match here, right? But it's very technical. So this is not something you would want to look at when you want to reason about your tests. Even with a good XML editor, you would have to kind of match these IDs in your head, or use search to find them or something like this. And this is actually by design, right? This is not designed to be very human readable. It's designed to be easily writable by any kind of testing framework. So as soon as something is started, the testing framework would write a line started. As soon as something's finished, it would write a line finished. And that's it. It wouldn't have to buffer anything at all. That's the idea, right? So because this is not very human readable, there's actually a second format, which we call the hierarchical format, which the Open Test Reporting repository provides a CLI tool as a reference implementation. This can actually convert from this event-based format to this hierarchical format. And this is a very rich format, and it's nested. It's hierarchical. So basically here, the root is the engine, JUnit Jupyter. And you can see there's a child here, which is this color palette tests. And this one has another child, which is the demonstrate palettes test, which is the nested class in this case. And that has another child, which is actually the flat default method Is it a method? Yes, you can see it uses a Java method source. Yeah, here's the class name. You can see, it's its nested class, and the method name is flat default. And you can also see there's full support for display names, and even you still have means to get stuff like unique ID from JUnit, or even like the type things, and provides you with a summary. And if you have a decent XML editor, you can actually use this and look at it and reason about it. It's not as opaque as the other one. Of course, this can also be used to generate some HTML report or whatever, right, in the next step. So this is relatively new, and if you haven't seen it yet, which you probably don't have, please try it out. And we're looking for feedback on this. Is there anything missing? Is there anything kind of over-engineered about this? Please let us know. We really want to know. All right. That already concludes the platform part. And yeah, I'm going to give you some resources and talk a little bit about what's next for JUnit. So on the horizon, we want to keep working on this reporting format. So we want to add support for attaching files, for example, screenshots or device logs. For example, if you have some Android tests or something like this. So it really should capture everything that is needed for such a reporting format to make sense of why it has failed, for example. There's a long-standing request to add an extension API for customizing the class loader used for tests. There's some use cases for this. This is something we finally want to address. And we also want to add support for parameterized test classes. So we've seen parameterized test methods earlier, but sometimes it really makes sense that all your test methods should be run with the same parameters, and you don't want to repeatedly, specify parameterized test annotation and the same source for all of them. You would really like to parameterize the whole test class with those, sets of arguments. So that's something we want to look into as well. And I already mentioned this new enabled or disabled in native image annotation that we recently added to Jupyter. And there's some more things that have come to our attention that we could do to be a better citizen in the Gradle VM native image space. Right now we have of course we use reflection. There's no way around some of these things. But there's some classes that we could write in a different way so they wouldn't require kind of early initialization during our runtime in Gradle VM. Basically, some things like this that we really want to improve upon, and so it's less work for other people, basically. And of course, it's an open source project, so it is and will always be open for any ideas you might have. I will talk about how to get ideas to us in a minute, but that's still the case. All right, some resources to get started. So there's a very good user guide, and just yesterday we created some nice short links for this. So this is the first time they're publicly unveiled, apart from the tweet yesterday. So if you want to go to the user guide, it's simply docs.junit.org. And the user guide covers mostly Jupyter, but also some platform aspects. And we keep improving that over time. And of course, if you see something missing in the user guide, we would also be interested on feedback for that. All right, what's next? Well, there's also sample projects. So the startjunit.org actually points at a GitHub repository that contains sample projects for the most commonly used build tools. And basically, if you haven't done any JUnit Jupyter development yet, that's where you should go and just get started. It also contains this example I showed previously with the multiple engines that you can run in a single run. So if you want to see that, also give it a go. Of course, there's also JavaDoc, api.junit.org has that. Yeah, so today's example code, I will push that to GitHub later. It's not committed yet, but I will do so after the session. So that should also be available for you to browse and take a look at and play with if you want. Yeah, we have time for questions. So, Marc, are there any questions now, or has Christian already answered all of them?
Not only Christian was here, but also Sam and Juliette. And they have been extremely active answering all the questions, as has our Anna. There was, some people were wondering about converting JUnit 4 to 5 in a large project. Do you have any tips for them?
Yes, I think there have actually been multiple projects on GitHub that have done this. I think the latest one I know of is from the Open Rewrite guys that have written kind of a converter that, so Open Rewrite, I think, is a framework that supports basically general AST transformations on large code bases. And they've written some conversion also from JUnit 4 to JUnit 5 or Jupyter, basically. I can share the link on Twitter later, and then, yeah. But if you Google Open Rewrite JUnit, you should find it.
Yes, I have noticed that. I haven't used it, so I was wondering whether any of you have experience with it.
Well, I tried it out on a sample project once. It worked fine, but I can't speak to like converting a big project.
Of course.
Sorry.
Yeah, same. So I know that we have some videos on it on our channel, or we have a video on migrating from JUnit 4 to 5 on our YouTube channel that I linked to in the chat already. And we have tools also in IntelliJ IDEA to help with that, Anna mentioned.
Right.
At the start of your talk, people were asking about using JUnit 5 assertions versus using assert J and Hamcrest. And you mentioned that you didn't want to reinvent the wheel. And I think also Christian said that you also use assert J. So basically you're saying we kept the assertions in JUnit 5 basic, and you can extend them with additional libraries. Is that correct?
Exactly, yeah. It's a basic set, so you don't have to pull in yet another library when you get started. But if you want to, write things in a more readable way at some point, you might want to consider using something else. So that's why we use assert J for our own tests as well. Yes,
perfect. I really liked your explanation about nested tests. So because I've seen them, but never written them myself. So basically, I think it gives you a way to combine multiple paths. Is that correct? So you set up, for example, in this case, do this, and then you can add.
Yes, let me get back to that slide. Yeah.
Perfect.
Yeah, I mean, we have a few minutes, so I can take this and even copy it somewhere here, and then we can see. So we can. Not sure if that's an IntelliJ bug. I'm using the early access release, so that's okay. Anyway. Okay, so yes, so let's run this. So fixing all the imports. So this is, a relatively kind of simple example, right? So what this does is you can have kind of something that you, for example, when you write, you can have multiple tests on this level as well. In this case, it's only one that just checks, okay, if it's empty, what should happen? You could easily write another one, like, I don't know,
not empty.
When, I don't know, like one operation is called pop or something on it. So when you call this, I think it should throw an exception, right? So you can write this. So that's, I think, what is it, legal state exception? I don't know. Let's see. The tests tell us. I don't want to insert an emoji. Sorry about that. Okay, there we go. Yes, now I should have that. So, it's an empty stack exception. Okay, that's the wrong exception. No, didn't know that. I think stack is probably one of the older APIs in Java. Yeah,
I think we've all been learning accidental things as well. I noticed people in the chat saying about using an underscore in numbers for readability that you used somewhere, and people saying that they didn't know that.
This one?
It's one of my it's one of my favorite things from watching other people's code or pair programming or programming in a group. You see people use stuff. Oh, I didn't know that was possible. So I'm really loving that today.
Yeah, that's cool. I mean,
okay, let me see if there are any open questions. Someone asked about testing concurrent code, where end states might not be deterministic due to race conditions, which is, fun times. Do you have any tips for them?
Yes, I mean, that's of course a more tricky testing problem. But I mean, Java has plenty of things that work there, like, for example, synchronizing things using a countdown latch or using futures or even completable future. I don't have any tests handy right now, but actually I write a lot of such tests at work because I'm working on things like test distribution at Gradle, and there's a lot of kind of concurrency going on there. So it's definitely the same testing problem whether you use JUnit Jupyter or some other testing framework. Basically, you basically have to rely on Java's kind of synchronization primitives. And
yes.
One thing that I think I use a lot is completable future and countdown latch to kind of wait on things rather than, thread sleeps. You should probably stay away from those.
Yes. Yes, sometimes you do need them, but overall I try to avoid and eliminate those. Well, I think we're running out of time. Do you have any famous last words or anything you want to share with our audience?
Actually, two or three more slides that I want to go through. So if the questions kind of have stopped now, that's fine. That's perfectly fine.
Yeah.
Okay. I just wanted to point out, there's other ways of asking questions. For example, Stack Overflow has a JUnit 5 tag, which we look at occasionally as well. And by now the user base is also large enough, basically, that the questions kind of answer themselves, so that not the JUnit team has to be involved there at all times. Of course, if you find something, if you have any kind of feedback, we would love to hear from you. There's our GitHub project, which you can just use to open an issue. There's also a chat tool that we use, which is called Gitter, which also has a lot of community members in there. So, just go there. And there's, last but not least, a Twitter account for the JUnit team as well. So there's multiple ways of interacting with us, for sure.
Perfect.
And I also want to take the opportunity to thank some of our sponsors, all of our sponsors. So you can actually sponsor JUnit, and IntelliJ is one of the sponsors, for example. This is just something, if you use JUnit a lot and kind of your employer benefits from it, you might want to consider, becoming a sponsor. So we're open for that as well. Basically, that's it's really great to have support from the community in this way as well. After all, kind of funding open source is kind of an unsolved problem, but we are kind of making some headway on this.
So does that mean that you are also getting paid to work on JUnit, or some people are?
Yeah, it's not like we collect huge amounts of money, but it's enough that we can use that money for that to some extent, and we also want to meet as a team early next year and just pay expenses and things like this. So we can meet for a week somewhere co-located, so we can work together and have that experience as well.
Perfect. Well, I learned a lot. Thank you so much, Marc. I think for my JUnit use in the past, I've merely scratched the surface. I saw some really interesting things that I can't wait to try out. So thank you very much for joining us today and sharing your knowledge.
Thanks for having me.
Thank you so much. Bye.
All right. Have a good weekend. Bye.